People, converting area units is, of course, you've got 1 centimetre is 10 millimetres, or 1 metre is 100 centimetres, or whatever. Converting area units, we do have to just be a little bit more clever. If you get confused on this, I strongly recommend drawing yourself a diagram, because this is a square that's 1 centimetre by 1 centimetre. So the area of this square is side times side, which is 1 times 1, which is 1 centimetre square, which says the amount of space it takes up on the page is the amount of space taken up by a box of 1 by 1. If I drew that same square, but instead of giving you the measurements in centimetres, I gave you the measurements in millimetres, how many millimetres would the side length be? 10 millimetres. So the area is still side times side, which is 10 times 10, which is 100 millimetres squared. What you can see from this is that while the length conversion is 1 centimetre equals 10 millimetres, the area conversion is 1 centimetre squared equals 100 millimetres squared. The same goes for our larger measurements. So 1 metre equals how many centimetres? 100 centimetres. But 1 metre squared is not 100 centimetres squared. What do you reckon it's going to be? 10,000? Because this length of 1 metre is 100 centimetres, says that square would be 100 times 100, 10,000 centimetres squared. Now, if you look carefully at these numbers, you'll see that the length relationship of 1 to 10, the squared relationship is 100, which is 10 squared. When it was 1 metre is 100 centimetres, 1 metre squared is 100 squared centimetres. So we can manage the prediction for a kilometre. A kilometre is 1,000 metres. So 1 kilometre squared would be 1,000 metres by 1,000 metres, which is 1,000 times 1,000, which is 1,000,000 metres squared. A kilometre by a kilometre on the ground is 1,000,000 square metres. So please notice that our conversions are going to be different for area compared to length. Now if we just skip ahead, even though we're just doing area, guess what it would be for volume? Perfect. So 1 centimetre cubed is going to be how many millimetres cubed? 1,000, because it's 10 cubed. So 1,000 millimetres cubed. And it makes sense if you think about it. If you drew that, here is 1 centimetre cubed. Its volume is area times height, which is side squared times height, which is 10 by 10 by 10. If that's 10 millimetres, I've cubed the length relationship. And it's really handy because, of course, when we're doing area, the units are centimetres cubed, and squared, and I square the length relationship. When I'm doing volume, the units are centimetres cubed, and I cube the length relationship. So 1 metre cubed is going to be 100 centimetres cubed So you can see that the relationship gets very large very quickly when we're talking about volume. Now this is cubing the length because that was 10 by 10 by 10. Remember that that's totally separate from the fact that I am measuring cubic units. A centimetre cubed says I've got a little tiny box that's 1 centimetre by 1 centimetre by 1 centimetre. The amount of space inside that is what I'm counting. How many of these little boxes could I have? So, A, you need to be able to convert between length and area and eventually volume units. Remembering, and again I like a diagram for this, if I'm given a measurement in millimetres and I want it in centimetres, it's a smaller number of centimetres to take up the same amount of space. So to go from a small unit to a big unit, I would divide. If I'm given a measurement in kilometres squared, and I want to know how many metres squared that is, that's going to be a lot more metres squared in that space. A large unit to a smaller unit, I will multiply. Do I need to write down that rule for you? No? Yeah?
Where does like an acre, is it acre or hectare that's used with where does that fit in?
Ah, good question. Acres and hectares. You guys, in area, we will also have a hectare. Can we see that? Yes, we can. The abbreviation is HA, and it is 10,000 meters squared. So it doesn't obviously have to be this shape, but a square block of land of 100 meters by 100 meters would get you a hectare. We don't need to use acres, but there's about 2.5 acres to every hectare. So
does that mean a hectare is less than a kilometre squared?
Absolutely.
Yeah.
This is massive.
Yeah.
So a hectare is 100 by 100.
So it's basically...
I thought a hectare would be something you use after like kilometres when it's so small.
A square kilometre is actually massive.
So why would you use a hectare?
Because it's a useful measurement. Like my block of land is, I've totally forgotten, 20 hectares or something like that. I can't remember. It's nowhere near a square kilometre. It's nowhere near a kilometre by a kilometre. It's like 450 metres by 500 metres or something like that. It wouldn't make sense to talk about it in square kilometres. Hectares get used quite a lot. Acres still do get used a lot. But I won't give you a question with an acres measurement in it. Anybody else? Problems with converting? All right. So, our area formulae, could you be on page 379 of your textbook? I'm still recording this, so can we get a move on? Okay. Shh. For those of you who are wondering, all I'm doing is looking at these formulae. For all your straight-sided shapes, we are measuring space in 2 dimensions. Let's start with a square. And as I'm sure you know, I'm counting how many square units fit into that shape. And the whole basis of my formulae is that I'm going, look, if it's 3 centimetres that way, and it's 3 centimetres that way, then I've got 3 times 3, which is 9 little squares. So this is 9 centimetres squared. You know this. The area formula of a square is side squared, 3 squared, 9 centimetres squared. And the reason it works is I'm just using multiplication to quickly count the number of little squares in that. The reason I tell you this is that the one thing that you guys don't seem to have internalized yet is that our different dimensions are at right angles. So when you're looking for the two dimensions in your shape that will give you the shortcut to find its area, you are looking for the dimensions at right angles. And the other thing I'm not sure that you've fully understood is that every area formula of a straight-sided shape is based on the area formula of a rectangle. So a square is a particular sort of rectangle. I gave you the square one there. I should have started with a rectangle. Length times width. And those two dimensions are at right angles. Every other straight-sided shape formula that you need to use is based on how could I make this into a rectangle. So any triangle at all, how could I make it into a rectangle?
From the top point straight down.
From the top point straight down?
Yes, another triangle of the exact same one.
I could go that way if I wanted, if that was right angled. Or if it was totally not a right angle, I could go this way. That would work. If it was one of our really, really funny ones, I can still come down to there in line with that and go across. What do you notice about the amount of space in the rectangle that the triangle takes up? It's half. So when I do the area of a triangle, base times height divided by 2, or half base times height, I use the phrase base times perpendicular height. And that perpendicular height means from the base of my triangle, where's the height that is at right angles? When I'm in the middle there, there's the base, there's the height that is at right angles. You're always looking for the two dimensions in the triangle that are at right angles to each other. The others are there to waste your time and confuse you, or perhaps for other measurements. All of the other formulae break down into rectangles. If you're really, really interested, something like a trapezium, how do I get that one to be a rectangle? Tom? Not sure whether you're saying that.
So I thought you were going to ask about the area.
Okay, never mind.
You could take the average of the two lines, the two long lines that are parallel, and so the when you connect them, it'll be a rectangle.
Yeah. Visually, what am I doing?
Just drawing two triangles on the ends.
What, just cutting there?
I mean,
If you cut
the
there
bottom right and the bottom left, draw a line up.
and move that triangle up to there, really badly drawn, and you cut there and move that triangle up to there, do I have a rectangle?
Yeah.
And so the length of the rectangle is the average of those two lengths, isn't it?
Yeah.
Shh. So that is the height of my trapezium, height of the rectangle. The length of the rectangle isn't the short length, it isn't the long length, it's the average of them. So the area is going to be the average of the two parallel sides times the perpendicular height of the shape. Every straight-sided shape comes back to how did this get to be, or how did we get from a rectangle to this? So if you want, it's a really good idea to work out for every formula, how did this come from the rectangle formula? For every straight-sided shape, look for the perpendicular 90-degree dimensions. That being said, the only thing that is not part of that, of course, is our circle, where the area is pi r squared, or part of a circle, such as a sector. In the same way as we need the correct fraction of the circle for the perimeter, we need the correct fraction of the circle for the area. So it's the angle divided by 360 multiplied by the area formula for a sector. And perfect working, you will need to give me the formula, substitute the values, your working, and the answer with units. Working if necessary. Do not start any question in the whole area thing without an area formula. You may have to solve some problems, e.g. in this shape here. Can't see a thing. Sometimes they will give you the area and ask you to calculate one of the sides. Still start with the formula. Area of a rectangle is length times width. Substitute in the values you know. 11 millimeters squared is x times 2.3. Divide by 2.3, so x is 11 divided by 2.3. X is 4.78. And we are measuring in millimeters. Now actually I'm a little incorrect there because I don't need to say millimeters, because the question says x millimeters, so the thing that goes in the x place is just 4.78, because then this would read 4.78 millimeters. If they'd just said to find x and hadn't said millimeters, then I'd say x equals 4.78 millimeters. There's a subtle difference there.
You don't test though, would it just not matter? Or
This is correct. Because they put millimeters there, that answer then goes 4.78 in there, and they gave me the millimeters. So technically, if someone was being an absolute nightmare, if you wrote millimeters here, they could actually take a half mark off, which is vicious. If they just wrote x, then they didn't give you the units, so you'd have to put the millimeters in. I won't get too stressed about it, quite frankly. I just want to know that you can find the answer. But when we were getting very accurate, that is something to be aware of. If you're finding the area of composite shapes, that is, let's find I don't want to do this, don't bother writing it. Find the area of concrete that I just poured for my shed slab, which is a shape like this. I'd give you enough of the dimensions that even if one was missing, you could work it out. So if I said this is 6 meters and this is 1 meter and this, I've forgotten what it is probably 13 meters, could you from that work out the length across here? Yeah, because you follow up the parallel lines. Obviously, if it's composite shapes, you work out, do I want to find the big shape and take away the cutout, or do I want to find 3 individual shapes? Up to you, as long as you work out your composite area. So, I've talked enough.